Hello everyone, in this video I will quickly show you the solution to question 30 in your tutorial sets. So we start with what we have to do. We need to show that the point 0a, which I will call a ball face, is in the boundary of this set. So we start off with the definition of the boundary. For every positive epsilon, we need to find 2 points, y dash and y double dash, such that they both come from the ball of radius epsilon around point A, and such that they both come from the ball radius epsilon, and one of them from the set S and the other one from the complement of that set. So the choice for y double dash is straightforward. We just take point A. That will meet both of the requirements, this one and this one. It meets this requirement because when you measure the distance between y double dash and A, which is the same as A, it will be 0, which is less than any positive epsilon, and it also meets this requirement because of this condition. And the first component in the point A and y double dash is 0. Now, for y dash, we need to do some prep work, and first we're going to focus on solving this equation. It's a trig equation, and that's how it solves. That's how it solves. We just use the that's how it solves. We use the inverse sine function, and we introduce this periodicity. It's not a complete solution, there are other solutions as well, but these two, or actually this sequence of solutions, which I index with k, will suffice for what we're about to do. Now, one thing which I'd like to observe about this solution is that the limit of this sequence xk is 0. This is because of the presence of this k in the denominator. Hence, if I use the definition of the limit, I can find an index k0 such that the xk0 in absolute value less than epsilon. In fact, this will be true for any index past this k0, but we only need one. That's why I just mentioned one index. And now I can present my choice for y dash. This is my choice. xk0 first component, a second component. I will show you now that this choice actually meets this requirement and meets this requirement. Yes, on one hand, if I measure the distance between y dash and a, given that these 2 points they have identical second component, the distance just reduces to xk0, which is less than epsilon by construction, and therefore y dash is in the ball of radius epsilon as required. On the other hand, the second observation I'll make is that the first component of y dash is positive, which meets this condition, and by construction again, xk0 is a point or a number which solves this equation. With a in place of y, and that's why y dash is in the set S as well. And that finishes the argument. Thank you very much.